Hey everyone, and welcome to This Explainer. I am so thrilled to have you here today. Our big goal for this session is to completely demystify the mechanics behind the moon's changing face. We've all looked up at the night sky at some point and marveled at how our closest celestial neighbor shifts from this slender, silver sliver one week to a brilliant, glowing orb the next, right? But how does that actually work? Well, today, we're going to break down the science, the geometry, and the history to show you exactly what is happening up there.
Okay, let's dive right into this. Here's our roadmap for today. First, the cosmic geometry. 2, the mystery of tidal locking. 3, the 8 lunar phases. 4, names of the full moon. And finally, number 5, the lunar effect and observation.
All right, part 1, the cosmic geometry.
So before we can really understand the phases, we gotta grasp the fundamental spatial mechanics of our closest lunar neighbor. Our moon orbits Earth at a distance of approximately 238,855 miles away. And while that sounds incredibly far, in cosmic terms, it's practically sitting right in our lap. To really picture this 3D cosmic triangle in space, the NASA STEM demonstrations team has this brilliant classroom analogy. Just imagine standing in a completely pitch-dark room. In the center of the room is a bright, bare lamp, and that represents the sun. In your hand, you're holding a little styrofoam ball, that's the moon, and your own head represents the Earth. As you turn your body in a circle while holding the ball out in front of the lamp, you're literally, physically recreating the exact orbital mechanics that dictate how sunlight hits the moon and reflects back to our eyes. It's a giant cosmic puzzle, but it all fits together perfectly.
Now, this orbital journey takes time. Specifically, it takes what astronomers call a synodic month. This is essentially a 29.5-day cycle, starting from one full moon all the way to its exact next counterpart. It's this very precise 29.5-day rhythm that dictates the entire changing sequence of lunar phases that we get to observe from the ground, month in and month out.
And you know, there is some truly beautiful math underlying this whole cycle. If we look at the elongation formula here, r minus r cosine theta, we can actually prove the geometry of the moon's phases. See, the distance between the inner edge of the visible crescent and the outer edge of the moon's disk directly relates to the angle of elongation between the sun, the Earth, and the moon. By measuring that curve, you are literally plotting the moon's position in its orbit relative to the Earth's sunline. Honestly, math has never looked so stunning.
Moving on to section 2, the mystery of tidal locking. Okay, have you ever wondered why, no matter what phase the moon is in, we only ever see one side of this lunar sphere? The far side of the moon is completely, utterly hidden from our view down here on Earth. So why is that? To get it, we have to look back at the early days of the moon. Shortly after it formed, the moon was essentially just this chaotic sea of molten lava, and it was spinning much, much faster back then. But Earth's massive gravity pulled relentlessly on that molten lava, physically stretching the moon and creating these massive tidal bulges. As the moon kept spinning, these heavy bulges were constantly being pulled out of alignment by our gravity. This created rotational torque. Think of it as an immense physical drag that acted like a giant cosmic brake, slowly grinding the moon's spin down over millions of years. And this brilliantly illustrates the ultimate result of that cosmic brake, exactly what we see today, a permanently locked near side. Over millions of years, that torque eventually synchronized the moon's rotation perfectly with its orbit around Earth. It takes the exact same amount of time for the moon to spin once on its axis as it does to orbit our planet. This is the phenomenon we call tidal locking, and it's the whole reason humanity has only ever gazed upon this one specific face staring back at us.
All right, section 3, the 8 lunar phases.
So now that we understand the invisible physical forces holding the whole shebang together, let's shift our focus to the spectacular visual results we get to witness in the night sky. Now, what's really interesting about this slide is how it charts the uninterrupted, incredibly beautiful flow of sunlight across the lunar surface throughout the month. The moon isn't actually changing shape. It is simply our viewing angle of the daytime side of the moon changing as it circles around us. Let's just quickly walk through the first half of this cycle. It begins with the new moon, where the side facing us is completely shadowed in darkness. Then, as it moves along its orbit, we get the waxing crescent, just a tiny, delicate sliver of light. By the way, waxing is just the astronomical term meaning we're seeing more and more of its illuminated surface. Next up is the first quarter, where exactly half the visible moon is lit up, and then we hit the waxing gibbous, where the moon is mostly illuminated, swelling right toward full.
But wait a second, if the moon passes between the Earth and the sun during a new moon and sits directly behind the Earth during a full moon, why don't we have solar and lunar eclipses literally every single month? So the crucial point is this. The moon's orbit is actually tilted by about 5 degrees relative to Earth's orbit around the sun. Because of this slight 5-degree tilt, the moon usually passes just above or just below the sun and just above or below Earth's shadow. Perfect alignments are actually really rare, which is exactly what makes eclipses so incredibly special when they do happen.
Section 4. Names of the full moon. When the moon does finally reach its full phase, completely bathed in sunlight, it has historically commanded our attention. Let's smoothly transition from the hard astronomical science into the rich cultural history of human observation. For centuries, Native American and colonial traditions utilized these highly descriptive names for the full moons as a way to predict seasonal changes and meticulously track time. Take a look at these. For example, January's wolf moon was named for the cries of hungry wolves in the dead of winter. April's pink moon signaled the joyful early blossoming of pink wildflowers, while August's sturgeon moon recognized the exact time when sturgeon fish were most abundant in North American lakes. These names represent such a deep observational relationship with nature.
Today, of course, we also hear a few modern terms tossed around in the news. You might hear about a supermoon, and that simply happens when a full moon perfectly aligns with lunar perigee, which is its closest physical approach to Earth, making it appear just a little bit larger and brighter in the sky. Then there's the famous blue moon. Despite the whole phrase, once in a blue moon, this simply refers to the second full moon occurring within a single calendar month. Fun fact for you, a blue moon graces our skies roughly every 2.7 years. So maybe not quite as rare as the saying implies, but still a really cool event.
And our final stop, Section 5, the lunar effect and observation.
So we know the moon pulls on our oceans, but does it pull on us? How does the moon actually impact Earth? Let's move to these concepts and see how this builds into separating the persistent myths from documented biological realities. On one side, we have these widely held human behavioral myths. The idea that full moons cause massive spikes in human birth rates or wild nights at emergency rooms. But on the flip side, we have genuine, scientifically documented biological facts regarding animal behaviors, specifically marine spawning cycles tied to lunar light.
To address the human myth directly, scientists conducted an absolutely exhaustive French study analyzing 38.7 million human births over a 50-year period. And what did they find? On a full moon day, there is only a microscopic, entirely unnoticeable plus 0.4% surplus in births. That's practically zero. The data definitively shows that the belief in overwhelmingly busy hospital maternity wards during a full moon is an illusory correlation. It's simply a myth, plain and simple.
However, real lunar effects definitely do happen. They just happen in the ocean. Marine biology is heavily tied to the moon. Certain coral species, like Dipstrostraea speciosa, actually use light-sensitive proteins called cryptochromes to trigger synchronized mass spawning during specific lunar phases. The marine bristleworm operates the exact same way. And of course, when the gravity of the sun and the moon align during full and new moons, the combined forces to generate extreme high and low tides, known as spring tides. So the moon's power is very real, it's just mostly affecting our seas.
Now, looking at this incredible perspective, our own Earth, seen from the desolate surface of the moon, kind of grounds us, doesn't it? It really brings our entire explainer full circle. The moon has been our silent partner through billions of years of cosmic history, constantly, reliably reflecting the light of our shared sun.
So how can you best observe and capture it yourself? Well, according to photography experts at Adobe, if you want to pull out your camera, don't actually wait for a full moon. The waxing and waning phases actually reveal the most stunning surface details because the shadows cast by craters are much longer and more pronounced. Furthermore, trying to photograph the moon just before sunrise or sunset utilizes the residual light near the horizon, which beautifully enhances the moon's details and natural colors.
I want to leave you with this final thought today. When you step outside and look up at the next waxing crescent, will you just see a pretty shape in the sky, or will you actually see the cosmic geometry? Will you envision that 5-degree orbital tilt, the millions of years of tidal locking, and the 238,000 miles of space between us? Remember, every single time you gaze up, you are staring at the exact same cratered face of the moon that every single human being in history has ever marveled at. Keep looking up, keep asking questions, and I will see you on the next explainer.